Okay, welcome back. This is part 3 of 4.6 because we're working on the third problem out of my little packet. And if you haven't done so already, which you should have, you should download this, print it. It's the PDF, the Unit 4, Vilseck PDF 4, no, Vilseck Unit 4 PDF. It's under Canvas, under the welcome. You should have already seen it by now. Hopefully, you have printed it. But we're in distance problems, and when we have distance problems, we set up our rate times time equals distance every single time. Doesn't matter, every single time. So it talks about two planes at the same airport at the same time. One travels north and the other travels south. So I'm going to call this north plane, south plane, because we're talking about two planes. One plane travels north and the other travels south at a speed of 80 miles per hour faster. What does that mean if one is traveling 80 miles per hour faster? So if one plane was 100 miles, what would the other plane be? It'd be 180. Or you could say it's 100 and the other one's 20. So one is either you're adding 80 miles or one you're subtracting 80 miles. You just got to make sure you know which one's supposed to be the faster train. It's kind of like that last problem we did with the time. As long as there's a difference of 80 miles between the two planes, we don't care which one you're adding or which one you're subtracting. So I'm going to read it again. It says one plane travels north and the other travels south that is 80 miles per hour faster. So this one's going to be R, and this one's R plus 80 because it said it was 80 miles per hour faster. So this one was R, and this one is 80 miles faster than that one. It says that in 1.5 hours. That means both of them are 1.5. It didn't say one stopped for a while or one left later. It said that in 1.5 hours. So my distance for plane 1 or north plane is just right here. Rate times time equals distance. So that'd be 1.5 R. Down here I have rate times time equals distance, or R plus 80 times 1.5. So that would be 1.5 R plus 120. Okay? All right, so we got that chart filled in. Now we got to figure out the picture and so that we can figure out our equation. So it says two planes leave the same airport. All right, here's our airport. That's our airport. And one travels north. So here we're traveling north. And one travels south. So there's our north plane. That's that one up there. And this is our south plane. Maybe we'll do different colors just to make it a little more interesting. There's our north plane. And this is our south plane. And it says the planes are 1,740 miles apart, 1,740 miles apart. What does that mean? Does that mean that this distance is 1,740? Does that mean this distance is 1,740? Or does that mean this whole distance is 1,740? That means that this whole distance here is 1,740 miles. What is made up of this 1,740 miles? It's the distance of the north plane. So we have north plane distance and the south plane distance. So this 1,740 is made up of north plane and south plane to get that. So that would be 1,740. North plane distance plus the south plane distance equals 1,740. We now have our equation and we can plug it in and we can solve it. So what is our north plane distance? Our north plane distance is 1.5 R. I like to put them in parentheses when I have more than one piece of information. Plus, what's my south plane distance? Right here. That it is. So it would be 1.5 R plus 120. Please put them in parentheses because if not, you will think that that right there is your north and that right there is your south. But this is my north and all of that is my south. My south plane distance is 1.5 R plus 120. All of that has to be my south plane. So now I can solve this. You go ahead, hit pause and solve it so you can practice that and check your answer. All right, so I hope you tried it. So we have 1.5 plus 1.5 would be 3R plus 120 equals 1,740. we subtract 120 from both sides. And we have 3r equals, that'd be 0, 2, 6, and 1. And then we divide by 3. So 3 goes into 1620. 3 goes into 16 would be 5 times. Oh, I need to make sure that's over that 6 better. 15, I subtract it, I get 1. Bring down the 2, that would be 4. That'd be 12. And remember, we keep dividing until we finish all the numbers. 0. So 540. What is 540? R equals 540. Now, let's read the problem again. It says, find the speed of each plane. So R is 540. That means north plane. I need to find some room here. Can we still see when I come over here? Yep. North plane is 540 miles per hour. South plane is 540 plus 80, so that would be 620 miles per hour. So we need to have both of those pieces of information on there, and we are done with the third example. Now I do want to have you try some of these, so if you flip over to the next page there, I'd like you to take time before the next video, and I would like you to try, which problems would I like? Let's see. Let's try this is 4.6, the packet. I want you to try number 2, let's see, 2, number 3, and number 4. Let's just try those 2 before the next video, and then I'll go over those because this is a harder section, so I want to make sure that you're getting some extra time with them. So this is from this packet, and it's 4.6 right here, and I just want you to try these 3, and we'll see if we need to make another video with more problems. So go and try number 2, number 3, and number 4. I want to make sure that you write your chart, you draw a picture, you write an equation, and then you solve it and make sure you answer the question. And then I'll come back and I'll answer those. It might be 3 videos for those also. So just try those, and I will see you in a bit. Bye.